Hello class, today we are going to look at being able to determine if a sequence is an example of exponential growth or decay. I'll be able to find the common ratio for an exponential growth or decay sequence, and I can write the recursive equations for real-world exponential growth or decay scenarios. So right now we're going to do a couple of problems that are not on your worksheet, but we're going to look at just figuring out what percents are as numbers that we're going to multiply, so by common ratios. So when we can write any percent as a decimal by dividing by 100. So we can take our 45%, divide it by 100, and we will get 0.45 as our multiplier. So if I want to do the same thing with 29%, again, you take anything that's a percent, you divide it by 100, and there is your decimal. 78% then is just going to be, another way to think about it instead of dividing by 100 is just move this decimal 2 places. So it's 0.78. This one always tricks people up because they want to think about moving the decimal place twice. They forget to put that little 0 in there. So if you are in your calculator taking the 4 and dividing it by 100, you will see you get 0.04. And if I have a decimal already in my percent, I still take it and move it 2 places, fill in that open circle with a 0, and do 0.018. Or if you go to your calculator and take 1.8 and divide by 100, you will get the same decimal. Okay, we're going to need this because we are now to your worksheet. We are going to be looking at geometric growth. So the first one says if a geometric sequence grows by 30% for each term, then the multiplier is really 1, which represents 100%, plus the 30% as a decimal. And 30% as a decimal is 0.3. So if you add those together, this will be our common ratio. Okay, let's look at the next one. If we're going to be decaying, that means we're taking it away. So I have 100%, but it's decaying by 30%, which means I only have 70% left. So you do 1 minus, turn your 30 into a decimal, and your calculator will give you 0.7. Okay, so let's take a look at problem number 1 on your sheet. It says terms in the sequence grow by 20% for each term. So you see the keyword grow and you see 20%. So right away, since I know it's grow, it's 1 plus. I take my 20%, divide by 100, and I get 0.20. I add that to 1, and I get 1.20. This is my answer. Okay, look at the next one. If I grow by 2%, again, you're looking at the word grow, so you're going to take 1 plus, and then you change your 2% into a decimal. And this one you got to be careful on, because there's that other 0 there in front of the 2. And so your common ratio will be 1.02. Let's try a decay one. Okay, if I decay by, I'm skipping to number 4, I'm decaying by 5%. So again, you see your percent, turn that into a decimal, which is 0.05, and do 1 minus now because it's decay. And so my common ratio is 0.95. Okay, here's one that says I'm increasing by, so that means growth. and it is 3.5%, so I'm just going to go ahead and take my 3.5, go to my calculator, divide that by 100. That's going to give me 0.035. Since it's growth, I'm always starting with 100%, and I'm increasing, so I add 0.035 to it, and I get 1.035 as my common ratio. Okay, how about if I decrease by 12%? Again, maybe the first thing you do is just say, I'm going to divide that by 100, so I know that decimal is 0.12. Always start with a 1. I'm decreasing, which means I'm subtracting. And if I take 1 minus 0.12, I get 0.88 as my common ratio. All right, so now let's look at a story problem here. It says the population in a certain town grows by 3% each year. Its current population is 4,200. What is the multiplier for R in this situation? Okay, so now we have some extra words, but the words we should see right now are grows by 3%. So it's growing. We remember that our R is 1 plus, and then we change 3% into a decimal, so it's 0.03. And so my common multiplier, or common ratio, is 1.03. Now we want to take this and write an equation for it. So if I know my common multiplier was 1.03, and I need to now do u sub 0. Okay, this is a little different from our u sub 1. Story problems, we generally start with u sub 0, which means when we go to our calculator over here, we're going to have to go back to our y equals, and now up here, I want you to put a 0. So put a 0 there in place of your 1. So I gotta move mine up a little bit. There, I'm gonna put a 0 in place of that 1 so that I don't have a 1 there, I have a 0. So double check that with your calculator. Maybe stop your video here and make sure your neighbor has it. Okay, so that's fixed with my calculator. Now my first term is just like I thought it was, right? So what did we start with in this story problem? We started with a population of 4,200. So I have 4,200 as my starting value. Remember, I always use the u sub n minus 1. And since I'm multiplying, right, I'm increasing by, and I've talked about my common ratio, I just take this previous term and multiply by 1.03. Now we're going to go back to our calculator and type this equation in. So again, making sure this is 0, u sub n minus 1, and then I'm going to times it by the 1.03. And I'm going to tell it where to start, which is 4,200. Hit enter, and go to my table. Okay, I want to know what it's going to be in 10 years. So you can see from my table that in 10 years, I'm going to be at 5,644 and a fourth of a person. All right, I'd like you to stop the video and try number 8. Once you're done with number 8, now we're going to take a look at number 9. All right, so I have a population of a fish in a small lake is decreasing by 15% each year. Currently, the lake has 800 fish. What is my multiplier? So it's decreasing, so I'm going to do R is 1 minus, turn the 15% into a decimal, so 0.15. So my common multiplier is 0.85. Now I'm going to write the recursive formula for the situation. So again, I'm looking at u sub 0. And in our case, our u sub 0 is our starting value, which is 800 fish. So I just put u sub 0 equals 800. The u sub n minus 1 is just notation, and I am multiplying it now by that 0.85. I'm going to go to my calculator and type this into my equation. Now, u sub n minus 1, I'm no longer multiplying by 0.1, I'm multiplying by 0.85, so 0.85. And I'm starting at 800, so I just type 800 right over there, hit enter. All right. And now I can answer whatever question they want me to. I'm just going to go look at my table and see what question they're asking me. So how many fish will there be in the lake 6 years from now? So they just want to know in 6 years. So I look at u sub 6 on my table, and I can see it's right there. There's 301 and almost 3/4 of a fish. That poor little fish. All right, the next question asks, how many years will the population be less than 200 fish? Okay, so when I look at my table, I want to see, okay, these values right here are my numbers of fish. And I got to figure out how many years am I less than 200. So you can see I'm at 217 here. I'm at 185 here. So 9 years I will be less than 200 fish in that lake. Okay, now I'd like you to take a look at number 10. Now that you've looked through 10, take a look at 11. We will be looking at some of these tomorrow, but I want you to try them independently. You can help your neighbors, you can work together, but make sure you're taking a look at this. All right, let's look to 12 because 12 is a little bit different. I want you to think about those story problems we initially had. We now have a recursive formula and we can make up our own story problem here. So it says the height of the bouncing ball is modeled by this recursive formula. What is the real world meaning for 100? So 100, remember, is our starting value. So if we're talking about the height of bouncing a ball, the 100 is going to be the initial height of the ball. So maybe it's 100 centimeters. Okay. And then what is going on with the 0.2? So you see right away it's 1 minus, which means something's decaying, right? And this is a decimal, which we can easily turn into a percent by multiplying by 100. And so what that means is that the ball's height is decreasing by 20%. Okay, and if you think about it, when you drop a ball, it doesn't bounce up to exactly where you dropped it off, right? It only gets up a little bit close to that height, and then it's a little less than a height, a little less, and it just keeps going down. All right, so hopefully this is enough to get you started on this worksheet, finish it off, and we will pick up tomorrow. Have a nice day.